In this video we're going to look at finding the derivative and the integral of the absolute value of x. The absolute value tells you that the value of x when evaluated will always be positive. So if you had minus x in here, it would become positive x. And we're going to think about integrating and differentiating this just by thinking what a derivative actually is and what an integral actually is. And looking at the derivative, we'll start by drawing out the graph. This is y equals the absolute value of x. The derivative refers to the rate of change, and since this is a straight line and this is a straight line, the derivatives are going to be constant. They're going to just be the gradient of the lines, and this is a decreasing line, so the derivative is going to be negative, and this line is increasing, so you're going to get a positive derivative. So if you find the gradient, you'll get this gradient as being minus 1, so the value of the derivative all the way along here is minus 1. There'll be no derivative there, and the value of this will be 1. You can calculate that using the standard gradient formula, and that's the graph that you get of the derivative. Just when x is positive, the derivative is 1, and it's constant because it's a straight line, and when x is negative, the derivative is minus 1, which is that line there. So you can write these statements about the derivative. You can say that the derivative of the absolute value of x equals 1 when x is greater than 0, and equals minus 1 when x is less than 0, which is exactly what this graph is showing, and it's not defined at x equals 0. So that's the expression for the derivative. And if you look at these, it should be immediately obvious. If you've got a positive value of x, you'll just have x divided by x, which is 1. Whereas you've got a negative value, you'll get this. You'll put in minus x, and the bottom, the absolute value will make that positive, so you get minus x divided by x, which is minus 1. And this is exactly what the derivative is. You could, of course, find it algebraically by using this expression. This is differentiation from first principles and involves a lot of manipulation, and someone else has made a video on that which I'll link to. Now, to look at the integral, an integral is essentially, in the way that we're thinking about it, the area under this graph. That's what the integral is. And we can break down the region into an infinite number of small squares, we'll call them I, and it's dx wide and d absolute value of x high. And this is your mod x axis, and this is your x axis. Y equals mod x, and you've got x going along there. And we can sum all of these, which this formula is the sort of literal interpretation of an integral. The sum of I equals 0 up to infinity, so that's adding up all of these little squares, and we're going to add them all across this area, and adding all of those squares up will give you this expression. And you'll notice this triangle only takes the positive values of x. We've got x positive here, and this is essentially your expression for an area of a triangle, half base times height. We've also got this triangle as well. That's a half all of the negative values times mod x, a half base times height. This should all be very obvious so far. And the area of this is defined as being greater than 0. You can't have a negative area, so we'll just make the area positive. And so the integral is all of this area, so adding these two triangles, which is combining these two formulas. You combine them, take a factor of absolute value of x. So you've got the positive x's and the negative x's, and you can combine those and just say that's all of the x values, which gives you this expression here, which is x absolute value of x over 2. The other way you could think about it is just filling this whole area in. You're going to have no negative on the y-axis because it's the absolute value is always positive. So this would represent the whole area of everything, and that would be x times mod x, all the values of x times that. Imagine adding all of these squares over the whole this enormous rectangle, or rather square. Just add all of those up, and well, we think that's going to give you double the area of the actual integral. So you imagine taking away these two sections, you're going to be left with half of this, so x, absolute value of x, over 2, which is this. So there's two different ways of thinking about the integral, and they give the same answer, which is this formula here.